So we were basically given a question one here, and we are asked to what? To find the gradient of A, right? Now, the first thing you do is when you are given a question like this, whether in your exam, your test, or your quiz, what you do first is to check that parameter given to you. We already know that the parameter is what? A parameter, right? Now, confirm that parameter if that parameter is a scalar or a vector. You know what I mean? A scalar. A scalar is what? Without what? Direction. Vector is magnitude and direction. Are we together? Now, looking at our parameter, which is A, we can see that the parameter is having just magnitude without direction. What are the direction in this case? Our I, J, and what? K. These are our directions. But looking at this parameter is not having direction. So what do? We apply the what? The concept of what? In the concept of what? Gradient. And what's the concept of gradient? Gradient simply says what? Partial I of what? Partial x plus partial g of what? Partial what? Y plus partial k of partial what? Z multiplied by our parameter, which is a scalar. And we have the parameter to be what? 6x squared plus 4xy plus what? 3xyz squared. Are we together? Now, if you do that, the concept, what you simply do is, what we do when solving gradient is we use one of these, we multiply with what we have here, which is 6x squared. We use this to multiply with what we have here, which is what? 4xy, and we use here to multiply with what we have here. If you don't understand, go back to our first episode on how we proved the equation for what? Gradient. Are we together? Now, with further ado, let's jump into the calculation. From what we have here, we can see that we are seeing partial I of partial x multiplying with what? 6x. So we'll simply write that to be partial what? 6x squared of I divided by partial x plus partial what? Partial 4xy of j divided by what? Partial y. And this will also give us plus what? This will be plus partial what? 3xyz square divided by what? Partial what? Z. And this is for what? K component. Now, what is this simply telling you? This is simply telling you to differentiate 6x square with respect to what? X. That's the meaning. Now, if you want to differentiate 6x square, remember the concept of differentiation. Nx n minus 1. This is the concept of what? Differentiation. So we apply this concept in differentiating what we have here. And if you do that, you simply have your 6x square differentiated. We will have what? 12x. So what we have here will be what? 12x of what? I. Now let's go over to the next one. Next one is what? To differentiate 4xy with respect to what? Y. Now, differentiating with respect to y, we are seeing y here. And if you apply this concept, we'll simply have this to be what? 1. 4x, and we are left with what? J. So you have 4xj. Now, what's the next one? The next one is to differentiate 3xyz square with respect to what? Z. Differentiating with respect to z, our interest is just this z here. So since our interest is our z square, differentiating z square, that will give you what? 2z. So what you have here will simply be what? 3xy multiplied by what? 2z. Are we together? And if you do that, you simply have your 2 multiplied by 3. That will give you 6. So this will be 6xyz. So what we have here will simply be what? Plus 6xyz. And let's not forget to add our component, which is what? K component. Now, after getting your solution, check your answer if that answer is still a scalar or a vector. Now, looking at our answer, we can simply see what? Magnitude and direction. And that tells you that this is a what? A vector. Now, you see that after calculating for the gradient of a scalar, we arrived at a what? At a vector as our answer. Please take note. what do you ask yourself first? The first thing is to ask yourself, is what we have here, is our b parameter a vector or a scalar? Looking at our b parameter, we can see what magnitude and what direction, and that tells you that it is a what, a vector. Now what do you do next? The next thing you do is to apply the concept of what, gradient. And what's the concept of gradient? The concept of gradient simply what, the concept of gradient is simply partial I of what, partial x plus partial j of what, partial y plus what, partial k of what, partial z multiplied. And what's the multiplication here? Is a scalar multiplication multiplied by our b parameter, which is a vector, to be what, 4x square y square z of what, I, plus what, 3xyz of j, plus 6x square y square z square of what, k. What's the next thing you do? You apply the concept. Now, applying the concept, you have this to be multiplied with what we have here. We have this to be multiplied with what we have here. And we also have this to be multiplied with what we have here. If you don't understand what we did, go over to our first episode, how we proved the equation for what, gradient. So you will know what we are doing. Now, with further ado, let's go over to what we have here. What we simply have here is they are telling you to differentiate your I component, which is what we have here, with respect to what, x. So we are differentiating everything here with respect to what, just x. Now apply the concept of differentiation. And what's the concept of differentiation? Nx n minus 1. That's the concept. Now, if you apply this concept in differentiating 4x square y square z of I component with respect to what, x, our interest will now just be on what, 4x square. Now, if you differentiate 4x square, that will give you what, 8x. And what are you left with? You're now left with what, y square z of what? Remember, what you have here will be I multiplied by I. So you have this to be what? I multiplied by what? I. Let's go over to the next one. So we have plus. The next one here, for your j component, we are differentiating j component with respect to y. Now we are differentiating what we have here with respect to y. So our interest is just what, y. Now if you differentiate y, you simply have what, 1. Are we together? Now if you have 1 there, what are you now left with? You are now left with what, 3xz. So here you are left with what, 3xz of what, j, which is what we have here, multiplied with what, the j component, what we have there. Now what's the next one? The next one is plus what, 6x square y square z square of what, k. Our interest is we are differentiating k with respect to what, z. You are differentiating your k component here with respect to what, z. And what z? Z square. Now if you differentiate z square, that will simply give you what, 2z. So what you have here will now be what, 6x square y square multiplied by what, 2z of what, k, such that what you have here, which is 2, can be multiplied with 6, and that will give you what, 12. So here you can have this to be 12x square y square of what, of z, and that's of what, k component. So what do you have there? This here will simply give you what, 12, because you have 6 multiplied by 2, and that will give you what, 12 x square y square of what, z, and this will be what, k multiplied by what, k. Are we together? Now if you do that, this will give you 1. Everything here is what, 1. Everything here is what, 1. And everything here is what, 1, such that you have your final answer to be what, 8xy square of z plus what, 3xz plus what, 12x square y square of what, z. Now look at your answer. What do you see your answer to be? We can see that our answer is just having magnitude without direction, and that's telling us that if you find the gradient of a vector, you will simply have a scalar.